welcome to this new tutorial. In this tutorial I want to show you how to do a fuselage for a Lockheed F-104 Starfighter, and yes, it is possible to do such a thing in Blender and to create it to be printed on a 3D printer. So I have an old plan, DXF plan of a Starfighter. I have created images, one image out of this, and I have put it into the back of these two windows. I have added two images on each window, and these images are bound to the views. As you can see in this case, one is to the right and the other is to the top view, and on the right window it is the same. We will now create a tube here, not a tube, it's a cylinder, and we will I will show you how to design this cylinder to get the form of the Starfighter fuselage. I will start by creating the cylinder, go into the front view, create the cylinder, align it to the view, and now the scaling is okay. It is made, the cylinder is made of 256 vertices, so the fuselage will have a good resolution. Now switch to the other view again and have a look what to do. First we go into the edit mode and we shift the cylinder to the right by 1 millimeter, so it starts at the cursor, and now we select the right side of the cylinder and we move it to the right to the end of the model. So a little bit further. Now zoom in here and look that it ends correct. This looks good, and in this view you can see it's also okay. So now I will cut this cylinder into about 20 wings with Control R. Yeah, 20 pieces, and we don't shift them, so now we can use these wings and edit them so they follow the form of the fuselage. Now we switch to a one window view and to the top view, and we will now scale these wings. At the first wing in front we can scale it just the Y and the Z value, X and Y and Z value at the same time, so we have a small circle at the start of the fuselage. And now I only zoom this by the X value, and this for every wing, so we see that the cylinder is formed to the correct looking. So, and on scale every wing to the size of the drawing, scale it by the X value, not by Y or Z value. Okay, it's possible to select more than one tube, one wing, and scale it at the same time. These turbine inlets will be created later. Oh, they have done something wrong. Control Z and do it again. Now select more than one wing and scale it by the X value. A little bigger. Oh, good. It looks good. So let's do the last wings at the end of the fuselage. It's very easy in this view to scale it. It will be a bit harder in the in case of the Z scaling that we will do at in the next session. So here we have our first version of the fuselage. Now we switch to another view and scale everything in Z direction. Okay, as you can see, I have scaled one time. I've forgotten to scale only in the X direction, but don't care, it's not too, it can be repaired very easily. Don't just scale it correct. Okay, in this case we must scale and we must move the wing to the correct position. First we try to put it into the mid and then scale it by Z, but it is not always easy to bring it to the mid position. Sometimes it works, but sometimes the eye of my eye is not good enough to approximate the mid. So you can move it later to the correct position. Okay, and scale it, move it, everything only in that direction. Don't scale here without the Z, pressing the Z button, because this will disturb the scaling we have done before in the X direction. Okay, here we are. As you can see, we are on the in the area where the turbine inlets should be. We will create these later. First, we create the tube or cylinder for the normal fuselage. Okay, it looks good till now. You can see the rudder there. We don't create the rudder with this scaling here. We will only create the fuselage, and the rudder will be added later. Oh, everything okay. Select it, scale it, and move it. Scale it another time, so it looks good. We don't create this part here. It's you can see when you follow the video. Only the round parts will be created here by these cylinders. Okay. Scale it, move it. Okay, move it a bit, and 3 more wings to go. Scale by that. Okay, it looks good. This one, scale it, scale it. Yeah, looks good. And the last one. And scale it. Okay, here we are. Now let's have a look how it looks. It looks good. There's a part where the glass of the pilot case will be later. It should look a bit, should have a different look, but I don't create it here. It's not that important. It's more important to show you how to create the turbine inlets in this cylinder. Now we switch to this view and have a look at it. There you can see one of the wings. It is going down where the turbine inlet should be. Now I select the part before this this inlet. Select by border select and press P and selection. And now we have two parts of this fuselage, a back part and a front part, and we put these on different layers so we can hide the first part and just create the turbine inlet for the back part. Okay, so we scale in a bit. Now we choose 2 points where the point on front and the part on back of the part on the back, and these parts, you can see them here, I have shifted them. I will scale them and I choose proportional edit mode with another proportional editing fall off. I use sphere at this in this case. Now I can press scale by the X value and I can rotate the mouse wheel button and tell the system how this turbine inlets should look like. Now this was not bad. Now I can switch to this view and scale it to be in the size the drawing defines. Yeah, this looks quite good. And this is the size the things should have. Okay. Another testing. Okay. This looks good. And now I go on to the right and select the second points here and scale it by X with the same parameters, and now do this, getting more and more to the right of the model. Deselect everything, select the next points and scale. In this case we use the inner drawing for the turbine inlets, as you can see here. No, this was not correct, so let's this was point and do it one more time with only one point selected. This one, okay, and now these 2 points there. Okay, looks fine. And the next one.
In Century 21, Counter-Strike seems like just another foreign game, but it isn't. It is different in many ways, and so are those who are fighting. In DPP, combat soldier logs 19. In Counter-Strike, he is 13. Fighting of the past 2 weeks continues today some miles away from Düsseldorf in giant F-104.
The drawing tells these tubes, these inlets look a bit other than shown here, but don't care. It's everything okay, like it has been done here. Okay, here we are. Now we have created these turbine inlets, and now we select the other layer, and we have both parts of this fuselage, the front and the back part. Now we will join them just to one object, select everything in edit mode, remove or duplicate vertices, and these two parts are glued together as one model. Now it is not printable because it has no size, and at the back we have there should be a hole, so I select the plane and delete it just by clicking delete faces. Now we have an open end. Now a very good blender function. We go into the edit mode, select everything, extrude it without moving. So extrude, and just X0, so it is not moved. We have the extrusion on the points. Now Alt S and -.3, and now we have told Blender to scale it down with a size for the wall of 0.3 millimeters. It is for 3D printing, it is one layer big. The thinnest wall the normal 3D printers can create, and now we have the model complete with a wall thickness of 0.3 millimeters. Now we can have a look at it. Is it solid? Yes, it is completely solid, completely waterproof. So this is printable when we cut it down to printable parts. It is too big for the normal 3D printer, so we will create a cube here, cube of the size of 180 millimeters, so 90 millimeters radius is told. Okay, this is the cube. We shift it 90 millimeters by the y-axis, and yes, it is okay. And we choose a modifier. I rename it to Rumpf. It's German fuselage. And now we can add, okay, there it is. We can add a modifier, a Boolean modifier. It is intersection, carve, and we use the Rumpf, and now we have the first part. Now we can create the next parts very easily by copying this box by 180 millimeters, and so on until all part of the fuselage was covered. We put the complete fuselage to another layer, so it is not viewed, it's not shown, and now we have these parts. We apply the Boolean modifier to get a mesh out of it, and now we have much parts that should be printable. The direction of this part is not correct, so first I will switch off the background images. Now we can select this and rotate it by the Z direction. Oh, not Z, it's X direction. So the parts can be printed from bottom to top. Okay, 3D cursor, and we rotate the complete fuselage by 90 degrees on the X-axis. Now we can, this can't be printed in this direction. We will rotate it by 180 degrees and shift it 180 millimeters, so it's standing on the Z0 value. And now we can move the other parts so they are on the correct level and don't make problems with the other parts. So we can see, okay, looks really good. So next one, minus 540 millimeters. Fuselage can't print it in one printing. We must create multiple parts to achieve this. The last part. Okay. We have one part that can make problems, and we must rotate it too. This is this part there. Rotate it by 180 degrees. Move it 180 millimeters and move it to another position. So this is printable. Some of these parts can be printed inside another object. This is not possible. No, this is not possible. But this part, it can be printed inside this part to the left. As you can see, and this little wing also can be printed inside. There are no double vertices. We join these two objects. Now we put this wing into one of these. Also no double vertices. Now we name these parts. Print 1, 2, 3 and 4. And then we will be able to export them to get into the slicing program. First we save the complete Blender file, Starfighter. Now we export it to STL. This was point 1, now point 2, point 3 and point 4. Now we can go to the desktop and start the slicer. I use KISS slicer in this case. Here we have our 4 models. First one looks very good, and now we can start to slice it without support. The printing speed is not too fast. You must have a look at the printing if it is too fast or too slow. So the slicing is almost ready. Only the green part will go through this model a bit faster than the blue calculation bar, and then this first part is sliced, and you can see if it is looking good for printout or bad. So just switch. Now you can see it's 1 hour and 42 minutes and the model is 16.46 centimeters by cube. And now we put this value, multiply it by 100 and 100 and 100. Multiply it, divide by 100 and 100 and 100. Now we have cubic meters, and we multiply it with 1630 kilograms, multiplied by 1000, and this part, or these two parts, they have a weight of 26, almost 27 grams. Very lightweight, but it is strong material, and it is possible to print such things. Now we put another model. I'll take this one. It is looking very interesting. Add it and as you can see, you can print these 2 parts, or 4 at this time, 2 parts, but almost 4 parts you can print in one printing job. You can try to add a 3rd model. No, it is not possible to bring it together on one printing bed. Perhaps by rotation. I will stop here now. You can see it is possible to create a ducted fan model with a blender and bring it to a 3D printer. So bye until the next tutorial.